I guess Brad's up next, and I see he's about to unmute. He's getting himself together, and hello, Brad.
Hey, can everyone hear me?
Yeah.
Yes.
Alrighty.
Yes.
Okay, let me, so I'm gonna try something I've not tried before because I got a new toy back and I'm gonna use it for this this presentation. So I got a Wacom tablet. It's one of these drawing tablets that uses a resonance pen to let you draw on it. I've got a few things that for this presentation that I'll want to show visually. We'll see how it works. I've been told once upon a time that there's sort of two styles of presentation, one in which you have everything laid out ahead of time, and the other in which you have the sort of general flow of it, but you kind of do it as you go. So I'm going to try more towards the latter, and we'll see how well that works. Let me go ahead and present my screen. So this, for those of you who saw the talk I gave a couple times back on the Jupiter EForth. This was sort of inspired by that. So basically, the Jupiter EForth had a couple of interesting properties, but one of the ones that sort of impressed me the most is that in a mere sort of 8 kilobytes, they were able to fit in basically a system not only for compiling Forth and interacting with Forth, but for editing a Forth image live. And so there's sort of there's the ACE. The other sort of reason that this is interesting to me is actually the AI bot collaboration that we've got going on with Don's robot boards, because one of the things that you might want for a robot board is a level of interactivity that sort of even goes beyond what is typical for Forth, where you're not only editing and adding words interactively, but potentially refining words. So let me show you what I mean by refining a word. If I can tap on the right side of the screen here. I'll jump right to the sort of the demo of the idea of the thing. So imagine that you've got a word that you're going to define like star, and let's say I define it like this so that it emits a plus sign, and then I have some sort of a loop. Let's say I'm gonna print several stars, and that's lovely. But then I decide what I'd like to be able to do retroactively is I want to change what I meant by a star, because I decided I really wanted an asterisk. So if I do that, well, the problem is that test is already compiled into the dictionary, refers to the old definition. And if I look at the set of words, there's 2 definitions for star sitting there. And so what I'd like to be able to do is this. I'd like to be able to redefine star and have it take the top word off of the dictionary and go and replace all of the prior definitions of a thing called star, so that now if I run that word test, I can go and have it hook up to the new definition. If I look at the dictionary, now there's a single definition for star. And in fact, maybe I decided that that's not the right name for that word. I should have called it should have called it asterisk. So maybe I want to define it that way, and then I can redefine star to well, that's the trouble with a live demo. But the idea being that you could redefine a word. Let me just put that. Let's try that again and see why. I suspect that I have still got some bugs that I didn't realize I had, which tells you a thing or two about it. But let's say I do this again. Let's see if a little bit of and I can even see the word test, and it refers to the new definition. So that's the idea here. the thing that I learned in this process is this is actually surprisingly tricky to get right. And as clearly demonstrated by that further bug that I thought I had gotten the kinks sorted out on. So I did too many things at once with this project. I was sort of trying to work on some of the preparations for Don's boards, but at the same time implement this feature because I sort of been enamored with it for some time and was curious to see how readily I could plug it into EForth. So the challenge with this sort of thing is that to make it possible to change the dictionary in that way, you have to sort of struggle with the way the dictionary is structured. And typically there's sort of two portions of the dictionary that are dynamic. You've got some point in front of the beginning of a word, and then some number of bytes for the name. You've got some other data that's maybe fixed in size, and then you've got the parameters, and both of those two things are sort of elastic. And the challenge is that when you want to restructure things, you have to not only sort of know where to glue things in, sort of going backward in the dictionary, which the dictionary helps you do readily, but you need to go back and understand enough of the structure of the dictionary to be able to make those revisions. And this, as we'll see, turns out to be a little bit tricky. So one of the first things that I did was I wanted to mimic the structure of Jupyter EForth a little bit more closely, and it uses a slightly different layout than EForth. So EForth, has the link pointer up at the top, and then it has a count and the flags sort of after that, and then only at that point do you get to the name, and so then you get this variable length name structure. And so if you were going to skip around in front of it, there's a set of conventional words to sort of do that. And then at that point, you get to the code pointer and only then on to the params. And the challenge with this is that when you're going to go and revise the dictionary, one of the things that you need to be able to do if you're in the presence of a dictionary that has multiple vocabularies is you want to have a way to walk the entire content of the dictionary. So the trouble is that you can follow the link pointers to walk through the dictionary, but ideally what you want to be able to do is sort of blaze through the entirety of it. And I should clarify one thing that I was trying to accomplish with this that's present in Jupyter EForth is that not only does it redefine words, but it actually compacts the dictionary. So when you change the definition of a word, you're actually recovering all of the space from the replaced word. So in this kind of an arrangement, one of the things missing is that you need a length to move on to the next spot in the dictionary. But you have a problem of where do you place it, right? If you place the link, say you want to place the size up at the very front, that lets you skip down this way. But the problem is that now you need to have a convention that lets you find your way let's see, I'm describing this badly. You need to be able to find your way down to the next. Let's see. Sorry, if you link from here to the next code pointer, and I'm doing that in the wrong color. This is clearly not. I have two versions of this little thing I threw together in a web page. One that makes the colors visible, and I thought, oh, let me have the colors toggle through. In fact, let me switch over to that version because I'm realizing it's hard to show colors without my palette visible. Anyways, I'm realizing that that's getting down in the weeds. The key thing is that what I want to do is be able to walk the entire structure of the dictionary and then do all of the fix-ups. But to do that, I have to understand two kinds of things. I have to be able to understand both regular words, and regular words are sort of composed, in a line. And then when I get to a word like an if statement, the problem is that it will have some compiled piece, and then there'll be some sort of fix-up that happens after that word. And I need to have an understanding of that structure. And so I borrowed a concept from Jupyter EForth that they call a compiling word. And so in Jupyter EForth, you can say compiler if, like you would use this to define an if statement, and you have to specify the size of the word, and then you do whatever setup that you're going to do to put in place the if statement, and then you give a definition of what happens when that word runs, and because you've spelled out the size of the word, you have the ability to have a stream of other words, emit something. And then when you get to an if statement, you understand that there's in the case of a 16-bit forth, two bytes of information there, so that if you want to print this word, you can then skip over it directly. And similarly, there's the same idea is used if you, for example, have a string. So you might have some sort of a string, and then it needs to encode the knowledge that there's some amount of storage here, and you need to be able to skip over it. But in this case, it's variable length. And so what Jupyter EForth does is stuffs it here. The structure that I picked, which I kind of regret in hindsight, basically looks like this. You have the name at the very top, and I put this elastic thing up here. You put the link pointer after that, and then you put the what I called an advanced pointer that brings you to the next word, not in the vocabulary, but just linearly down in the dictionary. And then I had a sort of a multiplexed field that, and I should say these are all 32-bit, a field with a count. And another sort of foolish thing that I did was at the same time I changed from some of the things that in EForth were 16-bit to make them 32-bit, which I think was in hindsight a mistake. And in here I put an offset for those compiling words to find your way to the runs definition. And then I put what I called an end slot, which is sort of the number of slots that a compiling word would use, sort of filling out that 32-bit word. And only at that point, the code pointer, and then the params. And what that lets me do is that I can follow links as usual. And from the link, I can find out the count and print the name of words if I want to list them in a normal fashion. But if I want to walk through the dictionary, if I have the link to the first word and I want to exhaustively cover everything, we're agnostic to which vocabulary it's in, I can follow these advanced pointers down. Now I did a dumb thing. This part I think was informed by another sort of goal that I had in mind, which is I wanted to be able to save these images, because this essentially creates a world where you've got your dictionary now is sort of your editing environment. And so you want to be able to save that editing environment. But I wanted to be able to make this environment something I could save and restore agnostic of where it was laid out in memory. So I decided to make all of these fields relative, so that rather than this being a sort of an absolute pointer with link or with advanced, I made these both relative to the position they're at in the dictionary image. That proved to be tedious. So let me now sort of switch over and let's take a look at some of the structure of the system. So things that I borrowed from some of the iterations we've had on EForth. I was able to use a C technique that I won't go into here called X macros that lets a list of things, a list of code, and then use it multiple times in different ways. And so I was able to define the primitives just sort of one line each in this header, with the exception of a few that are multi-line because we're dealing with double words, which is surprisingly tricky in C, if you want to just sort of do it carefully. And then this sort of gives me those core words, and then what that lets me do is have the inner interpreter be very simple. This would be even simpler were it not for some debugging. One of the things I ran into changing out so many things at once with EForth was that I introduced bugs that were hard to debug, and so I ended up having to introduce a lot of debugging code, which I think was a mistaken way to do it. I should have either started from scratch or sort of done some of these refactorings more carefully. But the sort of interior of the system sort of stays the same. There's a switch, and then I'm able to have each of the primitives. And this let me accomplish, but one thing that I sort of swung back from that Dr. Ting had done in some of his more recent iterations was he had started to build up the initial dictionary in code. I ended up, and this I'm still also not sure was a good idea, playing with the idea of moving it into some external scripts. And so I put most of the core of it in what looks largely like conventional Forth. And so this is, most of it is sort of the core of of regular EForth. But I introduced a few constructs that were, and I'll show you the thing that compiles this in a moment. But I ended up having to do sort of a mini compiler just to build this up. And then there's a few places here where there are cycles where a word needs to be defined, used before it is defined. But I don't sort of have all of the machinery in place to do it. So I ended up having to introduce a notion of a forward definition where I would reserve a space to do a fix up later. And one of the places where that jumped out is that, for example, in some of these compiling words, I wanted to be able to use sort of their full sort of definition in this style in which flow control words are treated as compiling words. And you'll note that they've got, in addition to being sort of mark and resolve and so the usual things, there's these annotations at the end for how they're formatted. And so a different way that you can look at all of this is in this interpreter, you can get a list of words. But for example, if I want to see how if is defined, it because the sort of dictionary structure is sort of fully self-describing, you can see you can do C on any of the words, and it sort of gives you back their full structure. And so if you get something even fairly complex output of what it works, when you have something like a string, you can see it understands this. I added one flourish that was missing from Jupyter. So in Jupyter EForth, you're able to define these compiling words, but the problem is that if you define your own word that stuffs something away in the space within the current definition, say you defined your own print quote, for example, the problem is that the built-in words know how to print themselves. Whereas if we take a look at the definition here for dot quote, you'll see that it is a compiling word. It has some notion of building up this quote string. It has the runs construct that I mentioned before, which was present in Jupyter EForth. And I added a lists extension to this, and this describes how a definition for how to list this particular type of word. And so when you add one of these words that is storing additional data in the current definition, it provides a way to list that word. Whereas, say, in contrast, if we look back at if, it doesn't have one because there's nothing to be printed. If we look at, say, oops, that one's not. That one's special. Let's see. I'm gonna actually cheat and go out here. We look at, whoops. So let's look for another interesting lists one. So we've got, oh yeah, dolet, for example. So for example, if we do look at dolet, this is sort of the innards of it. It is also a compiling word. It has some notion of what it does when it runs. It doesn't actually do, it uses an opcode, so it doesn't do any of that. But then it has built into it the plumbing to actually list it. So for example, when you have a number and you list the word, it's able to understand how to show that. So in general, the aspect in which you're able to list the definitions of words in the dictionary works reasonably smoothly. I can commend. There's some nice things about being able to walk the and do sort of a proper C versus, frequently you'll see definitions of C that are only able to partially decompile a word. The redefinition code, now sort of switching back, the reason this proves to be really tricky, because what you end up having to do is imagine you've got a bunch of words in memory, and now you're going to redefine this word, and then in front of that you've got a bunch of other words, and then here at the end you've got this other word that you're going to substitute in. Now Jupyter EForth does an interesting thing. In addition to reconnecting all of the pointers here to make everything work, it also moves this word up in to that location. And I believe the reason that they do that is that they're trying as best as they can to perturb as little as possible in the dictionary, because there are some edge cases where this redefinition doesn't work fully. And so I think that they're hoping that if they don't shuffle the layout of the dictionary too badly, they won't run into issues.
Brad?
Yes.
I work on a Jupyter Ace, and I think the 3.5K memory availability is probably the other reason.
Yeah, certainly. I mean, there's certainly a number of reasons why they were trying to structure it that way. But you'll notice in what the contrast I meant was that rather than doing the movement, what I ended up doing slightly different is that when you have gaps like this, I leave this word in place, and then I clobber this and slide everything down. Whereas what they do is they clobber this and move it into this location, which is sort of even more work to do all of the linkage. Now, the other thing is that as you do these moves, you have to do a whole bunch of fix-ups. You have to walk through all of these words, and you have to, if they have any internal references, those can stay the same. But if they have any links that are to words here, you have to adjust them to take into account any size change here. And similarly, if there are words here that reference definitions back here, you have to make those adjustments. Finding an order in which to do that, to sweep through and not cause any other problems, is shockingly hard, especially if you're trying to keep in place all of the link pointers, keep in place any of the any of the intermediate state. What I ended up doing that I thought was working, but apparently almost works given my botched demo there, is I ended up first doing all of the fix-ups without doing any movement. So I don't slide this region down until the very end. So I first fix up everything in place. I have to do this in a very careful order, because as I walk through a lot of these fields, you'll remember that I need to know, for example, imagine if one of these is one of these words, as I'm walking through it, suppose that it has itself a compiling word that has a variable length. I need to know about that variable length and take that into account as I'm doing this walking. Super tedious. If you look at the size of the code to give you a sense, up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 24. So about 24 screens for the core of EForth. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. You get the idea. It's quite a bit more code than the entirety of the core just to be able to do that redefinition. I suspect that there may be some subtlety. I haven't, so I've stared quite a bit at EForth's, Jupyter EForth's cleverness for doing this. They actually do it in a big chunk of machine code rather than implementing it in Forth, which I think in and of itself is fascinating. And of course, they're not dealing with this extra issue of the lists mechanism. And I should say I did leave one thing out that they added, which is they also support definer words, which have the same limitation where you're not able to sort of list their internal structure. So I don't know, I'm left with kind of mixed feelings about this experiment. It ended up being very tedious to get it right, very flaky. It also felt like something I couldn't do very incrementally. There were some things that I've done here that I think that I will want to carry over and keep. One of them, I'm gonna knock this screen out. One thing is that because I changed out the EForth interpreter to work this way, it's very portable. And so in addition to being able to run this version that runs at the command line, I've got a version that spits out a Windows application, if it decides to load on me here. Or if I did I fail to double click? Never mind. Not my day for demo. So there it goes. Okay, it's slow to load. They've added a new thing with Windows where the EXEs that get run directly seem to take a while to validate. So the same thing is here. I need to work on the terminal and a bunch of the plumbing, but my goal was to have the same version of this thing, the same version of this thing work both in Windows as well as just a command line program in what could have, that's running in the Linux subsystem. The other version of this is that if I also have a version that gets generated that can run, whoopsie. Where's my, oh, oops. I need to make, oh, it's and this is, of course, oh, what am I not seeing? Oh. Whoops. All right, I'm going to skip that demo. In any event, there's a version of it that works on the web as well. That version is able to, what I did with that, what is this? Oh, I see, I've got it here. The problem with, okay, the problem with the Linux subsystem is that it has parts of the file system that can be seen by Windows and parts that cannot. That's not the correct way. Oh no, that is. So here's the, if we can, let me zoom in so we can, but same, oops, same story. Lots of terminal issues that I need to sort out because it lists them all on one line, but you know, same kind of deal. Oops, and my terminal. Oops. I don't have a backspace key, so and I can't type today. Test 10 4 42 minute. So. In any event, I think I'm over time, so are there any questions?
Yeah, I had a question. This is Dave Henderson. Do you support Do you look at the decompiling and the online editing that the Jupyter Ace had? I assume this is somewhat related to be able to edit and redefine a word. And I didn't know that it decompacted, that it actually edited in place. I thought it went on the end. So that's interesting to me. It's a pretty cool presentation. Thank you.
Mm-hmm. Yeah, I know that was one of the things I realized this as I was playing around with it. At one point, I was like, well, let me find out where these are at in memory. And as I, explored sort of, where it's putting them, it's actually shockingly good at sort of trying to perturb as little as possible. And my guess is that because there are places where where things leak out. For example, if you have because it uses absolute pointers, if you have if you rely on the layout in memory of a particular word, and then you've done something to perturb the dictionary, you're going to quickly get into trouble. The other thing
that's interesting.
What's that?
Well, that's interesting. I haven't encountered any troubles with it, so that's interesting to hear.
Yeah, I mean, the specific example would be like, say you created a block and then you reference some location within that block. You have to be careful, because if you then redefine things around it, you can actually perturb where that block is. Generally speaking, if you're sort of just defining things, stuffing them into the dictionary, and mostly using redefine for editing or for fixing mistakes, that sort of thing, then you're generally fine, because you're sort of piling things on the end of the dictionary. But if you put it earlier in the dictionary, then it. The other thing that's interesting is that all of this sort of also works in the face of vocabularies, and some of that sort of naturally falls out of the careful way vocabularies are done on the ACE. But in any event, surprisingly hard to get the fiddly details right. Yeah, I'm not sure it would have been. So the relative pointers that I used, I think, made it harder in some ways and easier in others, because in some cases, relative pointers meant you could sort of assume that entire blocks of memory, areas didn't need to be adjusted. But you really do have to look at every word as you go and do the appropriate fix-ups.
Yeah, it looked to me like you need a pretty big test suite to keep this maintained and all that if you decided to go keep it. But also,
oh, go ahead.
Also, the editing, it seems like Jupyter Ace made some attempts on the editor screen, at least, to format things like the loops and things to tabify them. That was interesting. I don't know if you noticed that.
Yeah, and a lot of that with Jupyter Ace, there's another thing I'm missing, which is so I've got with C, I have the tabbing and all of that, and I tried to make it something where with Jupyter Ace, it has that built in for the words that are built in. So if you have flow control that's built in, it does tabbing. But if you define your own, you make your own flow control word with the compiler word, it doesn't know how to tab it. I have enough flexibility in place to allow for that. But what I'm missing is that in Jupyter AceForth, there's also the word edit that lets you bring up a definition. It essentially does the same operation it does for lists, not.
Yeah, that was really handy because of saving to cassette and loading back is a big pain.
Yeah, and it's a fascinating sort of general approach. I think it's sort of part of what attracts me to it is that the desire to you've already got the dictionary. It feels like a thing that has a lot of complexity. You might as well be able to reuse it. But I think what this exercise, at least sort of, unless I've come at it the wrong way, taught me is that the added complexity to make the dictionary more than right once ends up being so much additional stuff that it overwhelms any sort of savings versus, say, like the cost of having a separate editor and just flush the whole thing and reload, which is sort of a little counterintuitive, but maybe not when you consider that like there's a big difference between even being able to do proper like list definition of C versus an almost right definition of C. C in the SEE sense.
Yeah, it's interesting they did it more like 8K or I think 8K is down with it.
I'm hoping Don is on deck. Dave,
I am.
The other Dave wants to say something. I see Don.
Yeah, I wanted to say something too.
Okay. Dave Jaffe, Dave Henderson, Don Golding, address your questions to Brad in that order, and then we'll get to Don's talk.
I didn't really have a question, but John Draper asked Bill Ragsdale what program Bill used to create those nice D-chart images.
It's PowerPoint. The whole presentation was done on PowerPoint. It turns out they have some very good line drawing. Not much good for freehanding, but does a good job on blocks, lines, triangles, squares, things like that. They also have all the flowchart symbols in it.
Well, that's nice.
John wanted me to turn private messaging on, but I think it has to be turned on before we start the meeting, I believe.
No worries about it, Bill. Don't worry about it.
Yeah. We're having a good chat anyway. It's good to see you a long while.
Good to see you, Bill. It's been a while. I have to say that.
And dropped by a minute ago, and she said, say hi to John for me.
Who?
Wife Ann.
Wise Ann?
Yeah, she's the redhead. Remember Ann from...
Oh, okay. Yeah, I think I remember
Say
seeing her
yes.
on the thing.
Say yes.
Okay, yeah. Are you still selling that meta compiler?
Oh, that's a long time ago. It's
Yeah.
a long time ago. There was only, I think, sold 3 copies. You got one, Atari got one, and I forget who got the other one.
Yep, good old sleazy writer.
Don Peters, mute.
Hello. Is it my turn?
As soon as, if Dave Henderson has anything else to ask,
Oh, all I wanted to say was,
moot.
sweet, great. Well, that was a great demo. Thank you very much. It was very edifying. I appreciate it.
John Peters, mute.
I'm waiting to question. Go ahead, you guys.
So ask your question.
Okay, Bill Nelson or Brad Nelson, I heard you mention something about, and I didn't catch it, something to do with the web. As you may know, Dudley and I are making Win32Forth available from any browser, including a browser on a Macintosh. What was your quick mention of the web?
Yeah, so because I structured the interpreter around a very small set of words, and because I laid out the dictionary in a way where all of the words are relative, it doesn't depend on layout, I'm able to take a version of that the core emulator that's in the core of EForth and run that in JavaScript. And so let me give you a little sort of, I can splash that up on the screen, but basically rather than relying on server side execution of the application, what you end up getting is what you end up with is a version of the core of it that's been chopped up to run in JavaScript. And so the core interpreter just takes those same operations that were in the that were for the core words, and then the rest of it is this is just a snapshot of that dictionary, the initial dictionary image, and then this interpreter is able to run directly in the page rather than what I believe you all were doing, which is running on the server. So that within the page, you're able to have a small forth. There are a bunch of gaps in terms of how interactivity works, but I mean, it's, of course I can't type to save my soul today. So there's the basics of a forth there. I mean, the advantage is obviously that you can run it on the page without having to have a server to back it. The downside is obviously it's limited by the scope of this small forth. So, and there's issues like where would you put persistent storage if you wanted persistent storage and things of that sort. And I should say I've got the code for all of this up on GitHub. If you go to those of you, flags are GitHub, and this. I labeled this steno fourth, steno meaning narrow, but just a random string I picked for this particular fork of EForth. Not sure. I'm sure this is I suspect that this is a one-time diversion, and that I've had a negative enough experience, or at least with the pieces that are around redefinition. I probably won't keep it. The parts around portability were things that I meant to do in general with some of the work with Don and folks. So that may stick around, and undoubtedly this web stuff will get some more polish.
Yeah, it's very interesting. You know, when I gave a talk to Made in Space programmers, I mentioned about using deferred words, which is the original kind of simpler solution, but then it doesn't clean up all the garbage. Yeah. But yeah, they were very fascinated the fact that you could change a compiled system, you know?
Yeah. Yeah, there are some really goofy edge cases with it. Like the one thing that sort of helps with Jupyter EForth is that they have the sort of the core image is baked into the ROM, and so that none of that gets perturbed obviously when you're doing redefinition. Whereas when you're doing this all from like a snapshot, if you're not careful and you're trying to redefine something that perturbs one of the core pieces of plumbing that are in turn being used live, while if you try to redefine part of redefinition, you run into problems quickly. And I think that in general, like all sort of image-based systems like Smalltalk and others like this, there's pros and cons to doing it live with an edited image. I think what really soured me off though is I had hoped that it would keep some of the simplicity of Forth, and it ended up adding it. It felt like I was writing a tedious garbage collector, because you have to know all of the structure of the thing, and like the minute you're writing a garbage collector without sort of a concerted philosophy around it, it's just tedious and as you saw, buggy. So.
I wonder whatever happened to the source code for all of this.